Let me go back there. So when I asked you in the question, I said solve for t when vi equals 0. That's why that's there. Okay? Does that make sense? Well, if you plug in 0, if I plug in 0 for vi, like asked, right? That makes that whole term gone, right? Makes sense? A t squared equals b. And then you rearrange it for the t. Okay? Any other questions, guys? Anything? Please ask. Oh, actually, let me go back before I go on to the next one, because it's shown on the next one. Let's see if anybody gets this before I say it. Let's look at this when I solve this one for t. Since t was squared, the final step to get rid of the square was take the 1 of each side. Square root, right? Now, in generic math, when you're using x, y's, and z's that don't mean a thing, just practicing math, right? You guys should hopefully remember that if you ever have to solve by taking a square root of each side, your answer could be what or what? Plus or minus. Raise your hand if you remember that, or kind of remember it. Because of the nature of what a square root is, right? It's whatever something times itself is, and a negative times a negative is a positive. Therefore, it leaves the door open to two possible answers, right? However, I didn't put a plus or minus there. Not because I forgot. It's because this isn't generic math. This is math for a reason. This is math that follows physically things that occur in the real world. And why doesn't it make sense for this particular solving to put a plus or minus there? Yes. Very good. Time can't be negative, right? Yeah, a random x, y, or z could be a negative, so you would put plus or minus there, but time can't be. So I'm not going to bother putting that because that doesn't make any sense, right? But some quantities we're learning about are vectors and can be plus or minus, right? So if it wasn't a t and it was like a v, like coming up in the next set, then we have to include plus or minus. So you'll see when we solve equation 3 for vi, we put a plus or minus there. Now, since we haven't done real problems yet, which one is it? Would it be plus or minus? Well, it depends on the context of the problem. And we didn't give you a real problem yet. Usually, trust me, don't get worried about that. It's usually pretty clear what it should be based on the context of the problem. All right? But generically speaking, when we just solve for vi and don't have a real context to put in yet, we have to leave the door open to it being positive or negative, because we had to solve by square root. But other than that, any questions about any of those rearrangements that we need to do? Yeah, don't sit back there and be lost. Ask a question if you need it. I'm going to assume we're good. Yes. What's that? The F's and I's are subscripts. Final velocity, initial velocity. Okay? That's all they mean. What do you mean? Oh, like this? The exponent. Yeah, put it below. Put it below. You don't want to get that. You don't ever want to put it as a superscript, because that would mathematically mean like an exponent. Okay. So, anytime we use subscripts, it's always to distinguish. Like if there's multiple v's in that equation, like with many of these equations, it's to distinguish which one we're talking about. Vi, vf. We will, at times, have bigger problems, not today, but down the road that might have two different times in it. And we might call like one of them T1, T sub 1 and T sub 2, like a part 1 and part 2, just so we don't get them confused as the same thing. All right? Subscripts just distinguish things so we don't. If we just called both of those V's, we get them confused, right? Because one happened earlier, one happened later. So we call one VI and one VF. All right? Any other questions? All right, final equation. For whatever reason, most years, I think this is one some struggle the most with, getting it right, rearranging when we have to solve it for VF or VI. So let me just go over something real quick about that. Look at VF and VI right now in the original given equation. They're both trapped in a set of what? Parentheses. So in order to isolate a variable that's in parentheses, you have to first worry about getting rid of the parentheses. You can't get rid of the parentheses unless you move everything that's outside the parentheses first. So that's why, like for example, when I solve for VF here, the first thing I do is 1/2's on the outside. I need to move that. Because if there's nothing around the parentheses, they're not necessary anymore, are they? You know, if there's something on the outside, it has to be distributed through. But if we want to solve for what's in them, we want to get rid of them so we don't have to do all that and make it all ugly. So I got rid of the 1/2 by multiplying each side by 2, so that's how I get the 2d over here, right? The t's still on the outside of the parentheses, right? Written side by side, that means multiply, so I divided the t over, right? So that's where the 2d over t came from. At that point, once the 1/2 and t are gone, then are the parentheses really necessary anymore? No, they can be dropped, and now you can isolate what you need to isolate by subtracting over the vi in the end, which I did. And speaking of the parentheses not being necessary, and the final answer here, if you don't have the parentheses there, that's okay. I'm not going to be real picky about that, because at this point, there's nothing outside of them in the denominator, is there? So you could actually drop them there if you wanted to. But any specific questions on any of those? Yes? You distributed first? Did you get the same answers as me? I wouldn't, because you're making things harder for yourself. All right? By distributing, you're almost like going against what your goal is. Your goal is to get VF by itself, right? When you distribute, don't you attach something extra to VF? So I'm not saying you couldn't get there that way, but it's definitely not the easiest way to go. You probably have a lot more chances for mistakes. So if your goal is to get this thing by itself, if you go and do whatever, distribute in that case to it and attach more to it, it seems like you're just like making life harder for yourself, right? Move that over first. It's already ready to be moved over, right? So boom, move it over, multiply by 2. Move this over first by division, and you're going to be a lot better off, okay? Again, I'm not saying, like, you could get there that way, but it's taken a lot longer than the quickest way possible, which would just be to get rid of 1/2 and t right away to the other side. And like I said, you're getting into a lot more moves, and there's a lot more possibilities for mistakes then. Okay? Any other questions? All right, if there's no other questions, let me actually just flip back. Oh, no, equal signs are reflective. You're saying just like, what if I had all this on this side and that on that side? No big deal. But typically, well, you're going to see me in the book work and anywhere. Once we isolate the variable, it's usually on the left side because it just looks nicer that way. So you could flip an equation side to side. It's completely reflexive. Okay? Okay, but that's what you're going to have to get used to that or start flipping on your own, okay? Any other questions? All right. Let me go back, and I don't want to, spend a bunch of time on this, but I want everybody to wonder why I asked you to solve for t when vi was 0. Don't want to write anything down here. Just pay attention, okay? Because this is something you're maybe later on down the road you might have to worry about, but this is kind of FYI right now, okay? So let me just rewrite equation number 2. D equals VIT plus 1/2 AT squared. Let's try to solve for t, just together up here, without vi being 0. Remember, vi 0, this whole term wiped out, didn't it? Right? But let's try to solve for t without it. What problem do we probably see right away? What issue? I want to get t by itself, nothing 0. What issue do I seem to run into? Yes. It is, but that's not the big problem here. That could be taken care of if this other problem didn't exist. Yes. T what? All right. I think you got the right idea. There's a t. This one's t to the what power? First, this is t squared. Are those like terms? No. You can't smush those together, can you? All right. So that doesn't mean this is unsolvable. That means you'd have to use the quadratic formula. All right. Which, this is just FYI, you don't have to use that right now. If we have a real need for it later, we'll do a separate problem, slow it down, and remember the quadratic formula later. So, in pretty much all cases in the near future, when using this equation, if you have to solve for t, it's going to be situations where the VI is 0 and you don't have that issue anymore when that's gone, right? Then you could get that t just like we did. It's not impossible to solve for, but you have to use a slightly more advanced algebra than just rearranging. You got to use the quadratic formula. All right, but that's just pointing out why I wanted you guys to plug in VI equals 0 to do that one. All right, so we're still, as the week goes on, when we get more time, maybe tomorrow, I still want to go through and prove where equations 2, 3, and 4 came from. We're just going to jump in and start using them right now, though. So I asked everybody to bring their books today, so hopefully you have yours. Get it out and go to page 63. Yeah. Grab one, bring them back up, don't leave it. I'll take them with you. Grab one here if you need one. You need one too? Hurry up. Wherever we left off in your notes, I do not expect you to write down and copy out the problem itself. So we're just going to write when we do examples that are in the book, like we're doing right now. We're just going to write page 63, example 2. And I briefly mentioned yesterday there's a certain format moving forward now that we're going to start getting heavy on problem solving. After we read this problem in a moment, we have to list all our givens, and within those givens identify the unknown. That's step 1. You have to do it this way, else you're going to miss points on a test or a quiz, even if you get it right. Step 2 is writing down the equation or equations necessary to solve this problem. Step 3 may or may not exist. If you have to rearrange the equations, we got to rearrange them like we did last night. Sometimes they're already ready to go for what's being asked. All right. And the next step, once you have them rearranged, or if it's already ready to go, plug in the numbers, run the calculation, get the right answer with the right unit. All that's what I want to see to get full credit. So even on the simplest problems, even ones that you wouldn't even have to rearrange, there's still 4 points involved right there on the simplest of problems. Right? The more steps there are individually in problems, the more points there'll be on tests and quizzes. All right, so the best thing to probably do tackling any physics problem is to just read the situation and try to visualize it. You could even draw diagrams if you want. You don't have to unless I tell you to, but it's a good idea, especially if you're having trouble thinking about something. But you need to get a good understanding of what's going on. You don't want to just rip out numbers. If your goal in here is to get problems done as fast as possible and that's it, you're done. You're going to miss points all over the place. All right? You need to understand what's going on in general, and then start picking out the givens. All right? I don't care about any numbers if I don't know what's going on, right? So I'm going to read through it, focusing more on the situation than the actual numbers, then go back in and pull out the numbers, okay? So it says, describe the motion of a ball as it rolls up a slanted driveway. So we're rolling up a hill. They actually give you a simple diagram there as well. The ball starts at 2.5 meters per second, slows down for 5 seconds, stops for an instant, and then rolls back down at an increasing speed. The positive direction is chosen to be up the driveway. Let me stop right there. If it tells you which way has to be positive, you have to follow it. but I've said this before, if it doesn't tell you which way is positive, the direction we were initially moving is the what direction? Positive. Okay? Always stick with that if they don't tell you. The origin is the place where the motion begins. All that means is that the origin, like everything's starting at the bottom when the motion began. Okay? The situation starting there. It wants what the sign of the ball's acceleration is as it rolls up the driveway. We'll get to that. And more importantly, what is the magnitude of the ball's acceleration as it rolls up? All right. Let's think about this for a second. Both questions says as it rolls up the driveway. So we're only caring about the up part, not the down part, right? Because that's all that's being asked. So this is where we start connecting dots of stuff we learned in the past. Remember I said everything kind of builds on each other. All this stuff we learned for the last 3 weeks, we're not throwing away and moving on to something new. It's all backing up what we're using right now. So I'm rolling up this hill, and that way is the what direction? Positive. And of course, if something's just rolling freely, it tells us this, but even if it didn't tell us, we'd assume on the way up, you're slowing down because eventually you're going to come to a stop. So if I'm going up a positive driveway in the positive direction, and while I'm doing that, I'm slowing down, what's the sign of my acceleration going to have to end up being? Yes. Negative. Remember that? If we're going positive, and we know we're slowing down, acceleration's got to be negative. So as long as we pull out the right givens and run the equations right, the kinematic equations should come out with the right sign. But we should also know in our heads what this right sign is, so if I messed up and if I messed up and got a positive acceleration out, I should be able to say, hey, wait a second, that's not what we learned. I must have made a mistake somewhere. All right? So, and to get the magnitude, we actually have to run the numbers. That's just the size. So both should come out correctly, the magnitude and direction of the acceleration, as long as we plug everything in right. So now the numbers matter. So we know we're just rolling up a hill, eventually going to come to a stop before we roll down, right? So the 2.5 meters per second is the first number we run into. What do I list that as? I got 5 variables, right? 5 possible variables. We got VF, VI, T, A, D. Did I miss any? That's it. Okay. What does 2.5 meters per second have to be? VI, that's what we're initially traveling at, right? And know your units well. Somebody better not tell me that's acceleration, because if it was acceleration, what would the units be on it? Not meters per second, but yeah, Don? Right, so know your units well. You should never make mistakes with that if you remember your units. All right. It slows down for 5 seconds. That's obviously my what? Seconds. Time. By the way, real quick mention of this is going to be the same all year. Weeks ago, I told you we're not required to use sig figs in here, right? So that's why I'm ignoring the 5.00 and the 2.50. Without sig figs, 5 and 5.00 mean the same thing. All right? Without sig figs, 2.5 and 2.50 mean the same thing. Because we're not concerned about sig figs for reasons we discussed before. You don't have to write the O's just at the end, the zeros. Then it stops for an instant. So stops means what? Stops means what? Yeah. Is 0. And remember, what do they ask me in define? So we got all the givens, but within the givens, we also want to identify the unknown. What's it asking me in the end define? The what of the ball? The magnitude of its acceleration. And actually, they asked it in 2 questions. What's the sign and what's the magnitude? Well, this will find out both. All right? As long as we solve it right. So the main thing is we have identified all the knowns and the unknown, right? So if you watch the problem from here on a test or a quiz, you at least got 1 point if you got all that right. Okay? All of it, though. Some of it's not good enough. So if you only have some of the givens right, or don't identify the right unknown, then you're not going to get anywhere, right? It's not going to help you. All right, so now if we did get this all right here, it really should just be a matching game. Which one of the four kinematic equations will work here? I have VI, T, VF, need to know A. There's only one kinematic equation that has all 4 of those variables. Which one is it? 1, 2, 3, or 4? This is a matching game. This step isn't physics. This is, can you identify which one matches up? Cool. 1. Equation 1 in its given form is VF equals VI plus AT, right? We do have to algebraically rearrange it. But remember, I did say, and it does make it a little bit easier, at sometimes more than others, but if something's 0, you're allowed to plug it in right away, right? So VF is 0. When a term goes to 0, I just do that a lot. That's just how I show it. I mean, you can just put a whole X over it. But that whole thing's 0 because this given was 0, right? So I need to solve for A. That whole left side's 0 since that given was 0, so we subtract over VI and divide by T, right? The VI is added to the term with the unknown we're trying to solve, which is the A. So we subtract over V initial, divide by T, and plug in the numbers. And like we predicted by concept, which we should have already known, A is going to be a negative number, right? It should be, because we're slowing down, going in the positive direction. It has to be. And negative 2.5 over 5 is negative 0.5. And its acceleration, what's my units, guys? Go ahead. Good. Speaking of that, I probably should have said this earlier, but another good thing about listing givens, you could decide very quickly if you have to convert anything. But right away, meters per seconds and seconds, do those mesh? Yes. All right. If this would have been like meters per second and this one hours, could I have plugged in? No, we talked about that very early on. You got to watch that because sometimes there's going to be small conversions you have to do prior to plugging things in. This one was good though. All the units were good. They meshed. And that leaves me with negative 0.5 meters per second squared. So we answered what it asked. We got the sign, right? It'll figure out the right sign. And we got the magnitude. The magnitude's the number, right? Magnitude, we always said a long time ago, is a fancy word for the number, the size. That's 0.5. Any questions on that? All right, one more example, then I'll give you a homework set of these for tomorrow. Flip over to page 69, find example 3. I'm sorry, example 4. So we'll flip through this one. An automobile starts at rest and speeds up at 3.5 meters per second squared after the traffic light turns green. How far will it have gone when it's traveling at 25 meters per second? So a pretty simple situation here. A car's speeding up from rest, right? And we need to end up finding how far it went. How far means solve for what? V, right? So, go back, get out values. It started from rest, so that tells me a pretty important known. Start from rest means what? What could I list right away, eh? Good. VI equals 0. Speeds up at 3.5 meters per second squared. What's that, Cole? Good. And we want to know the D when it reaches 25 meters per second. What's 25 meters per second? Variable do we list that as a given as? 25 meters per second. Well, I list that as. Can't be a time, right? Yeah. Final velocity, that's what we get up to, right? And we already identified the fact that we're solving D. Now, before I go on, though, real quick, this is super important. If you don't pay attention to this, you will get burnt. That's points on this. Maybe not in this problem, but some. When A is a given, we always have to think to ourselves, do I leave it positive or should I slap on a negative? Sometimes you're going to have to slap on a negative. How do you know is because of what we learned about the speeding up, slowing down stuff. Did this problem ever tell us anything about a direction? No. So the way I'm speeding up in, we should assume is a positive direction, right? So let's say we're speeding up that way. And we are speeding up. You literally use the phrase speeding up. So if I'm going in the positive direction and speeding up, my A better be what sign as well? Positive, plus, right? So that just tells me that I shouldn't slap a negative on here. But if I slapped a negative on there, that would mean slowing down. That's not what the problem's saying. But sometimes you're going to have to. Don't just assume that they're good. The only time you could assume you're good is if it physically puts a sign on it in this problem. If you see a plus sign in front of it, that guarantees you it's positive, all right? They're not going to fool you like that. If they put a minus sign on it for you, you could trust that. But if they don't give any sign on it, you need to stop and think, based on the scenario, should I put a negative on it or leave it positive? Because sometimes the answer is I need to put a negative on it to make sense of what's going on. And you don't want to get burned on that. There's other values kind of like that throughout the year, but the one that matters the most right now with that is acceleration. Be careful with that. All right. So what equation am I going to use? 1, 2, 3, or 4? Ethan? Looks like 3, which would be VS squared equals VI squared plus 2AD. VI is 0, so I can get rid of that whole term. And therefore, if I solve for D, it's going to be pretty simple algebraically. I just divide over 2A, right? So D will equal VS squared over 2A. Plug in the numbers, and I want to say something here as well. I'm going to give everybody a pretty important suggestion, because this is a mistake that happens all the time, even after I say this. This isn't that ugly of a calculation, but there's multiple things going on. We have a squaring in the numerator and a multiplying in the denominator. There could definitely be a lot more going on than that. But here's the deal. I suggest to avoid doing a fraction problem in your calculator when there's even a few things going on in the numerator and denominator. Otherwise, your calculators are programmed to do strict orders of operations. If you don't plug in everything perfectly and understand that, even though you have everything right up to this point, there's a really good chance your calculator will give you the wrong answer. All right? To avoid that issue on any problems with the fraction involved, what I would do is I would figure out the numerator separately. Figure out what 25 squared is, if you don't already know. Then, separately, do 2 times 3.5, which is 7, right? Then, once you have that as a individual number divided by an individual number, you can't go wrong that way. You won't make a mistake. But what happens a lot is people will just plug this in and do 25 squared divided by 2 times 3.5. Just straight up like that. And what your calculator will actually do, it will divide the 25 squared by 2, but then it will take that answer, because it's programmed for strict orders of operation, then multiply it by 3.5. That's not what it's saying to do, is it? It's to divide by that quantity down there, right? So the only other option would be this, if you don't want to do it separately. That put your whole numerator in parentheses, divided by your whole denominator in parentheses in your calculator. It'll do it right that way as well. But if you do bits and pieces, you're probably going to have all the right work and miss a point because you didn't plug it in your calculator correctly. All right? No matter how many, I say that at this point every year, but there's always stubborn people that won't follow that. They'll miss points all year because they don't do what I suggest. And they get out answers that are false because of the way they're plugging it in. So if we plug it in correctly, and again, I do apologize. These are much nicer to use, but we're not supposed to hand out something that gets shared a lot. So you guys will have to deal with the calculators on your Chromebooks, okay, unless you have your own. If I undo this correctly, I get out about 89.3. I'm rounding that off. We're not using sig figs. It's actually a long decimal. Round to 2 or 3, or I'm sorry, 1 or 2 decimal places is always fine. And that's a D, so it's in what unit, guys? That would make sense. Go ahead. Meters. And again, we didn't have an issue on this one, but all the units were good, right? Meters per second squared, meters per second. There was no converting necessary, therefore the D will come out in meters. So really, it's just, can I get the givens out right? Can I play the matching game with the right thing? And if I have to do algebra, I need to do the algebra. Pop in the numbers, spit out the answer. A lot of times these kind of problems are just referred to as like plug and chug problems. You find the right equation, you plug it in, you chug out the answer, right? Pretty much the majority of algebra-based physics is that. You'll see there's going to be lots more equations that come. But it's always going to be, can I get the right givens? Did I pick the right equation? Equations? Did I do the algebra? If you can do that, you'll be fine in here. All right, your homework. going to be off of several pages, so write this down. Remember about the acceleration sign thing I warned you about. It may come up. Page 64, 6, 8, 10. Page 65, 18 and 20. And then page 69, 26 and 28. All problems are solvable. So if it seems like you can't do it, you missed something somewhere. Okay? Never going to give you a problem with too little information. But on the flip side, some problems will give you junk information, so watch out. Alright, read them carefully. Have those all attempted for tomorrow, just in your notebooks. Don't have to turn it in on Squid or anything like that. Get them all attempted. We'll go over them, probably do another set on top of them. And also, at some point tomorrow, we'll go through more about the origin of some of those equations.